In a world increasingly shaped by dynamic interactions between people, platforms, and institutions, there's a growing need for a unified framework to model human decision-making systems. Whether we're analysing traffic patterns, stock markets, dating cultures, trade wars, which is very relevant in the date, or viral memes, at the core of every system lies the same fundamental element: sentient agents making decisions under constraints and interacting with each other, of course. This video introduces a theoretical model in progress designed to simulate and analyze such systems using a blend of psychology, economics, game theory, and statistical mechanics. The aim is to provide a versatile lens through which we can understand and predict emergent phenomena in social contexts. The Sentience Kernel. At the heart of this framework lies the Sentience Kernel, a conceptual model of the individual as a decision-making agent. Unlike classical models that reduce people to rational optimizers or simple stimulus response machines, this kernel seeks to simulate motivated cognition, a being that acts based on emotions, archetypes, inner conflicts, memories, and drives. This is where Jungian psychology becomes foundational. Jung's model of the psyche, composed of archetypes, complexes, the persona, the shadow, and the process of individuation, offers a rich vocabulary for simulating irrational or unconscious motives. Rather than treating these as noise, the model embraces them as essential input variables. Next up is decision-making, where game theory meets transactional analysis. Once we model the psyche of individual agents, the next question is, how do these individuals interact? This is where game theory comes into play. It provides the mathematical language to describe strategic interaction, competition, cooperation, negotiation, deception, signaling, so on and so forth. Game theory tells us what choices an agent might make in the presence of others, based on perceived payoffs. But traditional game theory assumes fixed preferences and rational actors. That's where transactional analysis steps in. Transactional analysis offers a way to model interpersonal communication, not just the strategic content, but the emotional subtext. Through ego states, parent, adult, child, and recurring social scripts, transactional analysis helps us calculate payoffs based not just on utility, but also on emotional and psychological needs. A decision may seem irrational in classical terms, but might make perfect sense with a dysfunctional script. And that's critical for modeling real-world behavior, considering that most of game theory sort of, it flakes out when you're considering irrational behavior. Now, about emergence, from individuals to systems. Now that we can model agents and their interactions, we ask what happens when millions of these agents interact over time. Here we turn to statistical mechanics, which allows us to study how individual behavior scales into population-level phenomena. The same mathematics that governs phase transitions and gases can help explain tipping points in culture, consensus formation, or market crashes. Phase transitions would be, of course, really helpful in this, in modeling this. Small micro-level performances, when multiplied across a population, can lead to large-scale emergent behavior. This is where the metaphor of quasiparticles becomes very useful. In physics, quasiparticles are emergent phenomena. Well, quasiparticles are a form of emergent phenomena, collective behaviors that act as if they were discrete particles. Similarly, in social dynamics, a group may behave like just a single unified actor in response to certain signals. Ta-da! Especially under pluralistic ignorance or social conformity. One person's treatment of you might cascade through a group until the whole group seems to behave like that single person, because they become a social quasiparticle. Practical applications of this framework can be applied to a wide range of domains, for example, traffic modeling, human behavior under constraint, delay, and feedback. Stock markets, and also, traffic, it could be that large groups of vehicles behave like a single entity, Could be. I'm not saying it would be, but you can certainly model it. You can certainly model parts of traffic jams as, it could be, the behavior could be reduced down to just 2 or 3 entities that are causing the entire thing, and maybe the entire segments of traffic might just be following the behavior of 1 or 2 vehicles. Well, 2 or 3 maybe. Stock markets, emotion-driven trading, herding, and cascades. Dating dynamics, signaling, plausible deniability, game theoretic asymmetries. Trade politics, barter, trust, betrayal, and strategic ambiguity, crowd behavior, groupthink, mobs, and public sentiment swings. Each of these Each of these involves sentient agents making decisions in interdependent systems, the perfect playground for this model. But it's still a work in progress. This project is a work in progress, part theoretical research, part personal journey. It draws from multiple domains to build a unified structure. Psychology, Jung, and I'll probably integrate some more stuff. Social communication, transactional analysis, it's also like integrates with psychology. Strategic decision making, game theory, whose sort of payoff matrices you sort of calculate from psychology and social communication. And scaling and prediction. How you can use statistical mechanics to sort of scale this behavior up from individual level and predict the behavior of emergent social entities, sentient entities like global corporations, or just, multinational corporations, or just two normal mid-sized corporations interacting with each other. Eventually, it might evolve into a book, a simulation toolkit, or even a software kernel, a kind of social operating system that lets us reason about the human layer with clarity and precision. Closing thoughts, modeling sentient agents is the holy grail of social systems theory, in my opinion. Once we can simulate how a person thinks, feels, and chooses, the rest is a matter of math. Oh, by the way, one thing that I did not include, which forms a really big part of this entire discussion, is the concept of free will. I'm going to be incorporating that and probably will give a sort of an explanation of how I incorporate that as well. So the rest is a matter of math, but that math must be built on a deep respect for the irrational, emotional, and archetypal roots of human behavior. We are not merely nodes in a network. We are stories, egos, myths, and fears wrapped inside skin. This project aims to capture that truth and build something real with it. Thank you.